Hello everyone, happy to see you here. Welcome back to my channel Hi Mathematics. Today we have great algebra question. We know that a square minus b square equal to 12, and we need to solve this question for integers a and b. So if you have your solution, your answer, you can also write it in the comments below, and then we will check your answer, so it will be really interesting. Okay, so first of all, on the left side we have difference of squares, and everyone should know this formula. This is a classic school formula. We can easily expand it like that. We can write it as a minus b times a plus b, okay, a plus b equal to 12. Right now, let's think a little bit about this 12, because on the left side we have a product of two values, of two parentheses. That's why let's express this 12 as a product of two, in this case, as a product of two constants. So let's do it. So how can we express this 12? There are a lot of cases, but basically we will reject a lot of it in the future. So that's why let's start with the basic one, I guess. 12 times 1, this is the first case. How can we express it? 1 times 12, we can express it as well. 6 times 2, we have 2 times 6. We have 4 times 3, this is our fifth case, and 3 times 4. We have a lot of cases, and right now I don't want to talk about negative ones, so let's start with the positive value. So we have 6 positive branches, and don't forget about the negative branch, because 12 is equal to minus 12 times minus 1. So let's start only with the positive one, and then we can quickly, instantly solve a negative one without any problem. So we're using one really interesting trick. So that's why I'm going to write a fixed system of equations quickly for better understanding. Let's start, for example, right here on the left side. So a minus b, a plus b. So a minus b equal to 12, a plus b, so a minus b equal to 12, a plus b equal to 1. This is our first system of equation, and let's quickly write our second one. So we just swap this constant, so a minus b equal to 1, and a plus b equal to 12. This is our second one. Our third system of equations, we are talking about 6 and 2. So a minus b equal to 6, a plus b equal to 2. The fourth system of equation, and don't be scared about this system of equation. We can solve it instantly in a few seconds. I'm going to show you a really interesting trick. So our fourth system of equation, a minus b equal to 2, and a plus b equal to 6. We go to the fifth system of equations, a minus b equal to 4, and a plus b equal to 3. And the sixth one, so we have a minus b equal to 3, and a plus b equal to 4. And right now, a few words about all the system of equations. As I said before, we're interested only in integers, so that's why just look closely at all this system of equations. There is one really interesting method. How can we solve this equation with the method of addition? Just look closely at each of these equations. When we add both equations, we have, for example, 2a right here, but we cancel our b, so we have a product 2a on the left side, and we add in this constant. So that's why we can easily reject an odd values on the right side, because basically we can't divide it by 2. What I mean right now, just look closely at this system of equations. We have 2a equal to, right here we cancel it, we cancel this b, so 2a equal to 13. So what I mean, just look closely what I mean. Solution, I write it as solution. For example, let's solve first of all this first one. So we have 2a equal to 13, and from here our a equal to 13 half, or 6.5. And right now, as I said before, we interested only in integers. So that's why exactly at this moment, when we have an odd number and an odd constant on the right side, we can actually get rid of these pairs only if you need to solve this question completely. You just need to solve each of these system of equations. In our case, we're interested in integers, so that's why we reject this system of equations. What about this one? 2a equal to 1 plus 12, so we have symmetrical coefficients. That's why we reject this second pair as well. As I said before, we just solved the question real quickly. What about third one? 2a equal to 6 plus 2 equal to 8. Yeah, this is good for us. So we have an even number. So basically we can get integer 8 from here. So we're interested in this. So I just want to underline this third. What about 4s? 2 plus 6 equal to 8. Yeah, we're interested in this. We're interested in this. And what about these 4, 3, 3, 4? We have 7 on the right side, so basically we can actually get rid of this, pair. So I hope you understand that we're interested only in two cases. We have 6, 2, and we have 2, 6. So we have third system of equation and fourth system of equation. But as I said before, we forget about, for a few seconds, we forget about negative parts. So that's why our four system of equations, that's why let's underline it right here and let's write our four system of equations. So we're interested in. So we are interested in this one, a minus b equal to 6, a plus b equal to 2. Second one, we just go with this one, a minus b equal to 2, and a plus b equal to 6. And as I said before in the beginning, we forget about negative branch because there will be like a lot of cases. So that's why we're interested in the negative cases as well. So we have a minus b equal to, right here we have minus 6 and minus 2, yeah, minus 2 and minus 2 and minus 6. So that's why let's write this system of equations. I just want to gather all the system of equations together. Don't be scared about it. I just rewrite 2 from here and I take 2 negative branches. So minus 6 and a plus b equal to minus 2. And the last one, the fourth system of equations, a minus b equal to minus 2 and a plus b equal to minus 6. Okay, so we have fourth system of equation, and right now we can solve this system of equations according to the same logic as I said before. So we added, so the first system of equation, when we added 2a equal to 8, so 2a equal to 8. From here our a is equal to 4, but what about b? But b is equal to 2 minus a, but b equal to 2 minus a. So we have 2 minus a equal to 4 minus, sorry, not like 4, but 2 minus 4 equal to minus 2. So we have our first pair. Our first pair, we have 4 and minus 2. Okay, let's go to the next to the next pair. We can solve it real quickly. So we have the same thing. We have the same multiplication, 2a equal to 8 as well. And from here, our a is equal to 4. But what about b? But b equal to 6 minus a. That's why we have from here 6 minus 4 equal to 2. And we have our second pair. We have 4 and 2. Third pair, right here we have a negative case, so we will have a different root, I guess. So we have 2a, the same addition, equal to minus 8. And from here our a is equal to minus 4. But what about b? But b equal to minus 2 minus a. So but b equal to minus 2 and minus a equal to minus 2 plus 4 equal to 2. So we have our third pair, minus 4 and 2. And our last pair, our fourth pair, let's write it. So let's do the same thing, to a equal to minus 8. Yeah, to 8 equal to minus 8 right here. And from here, a is equal to minus 4. But what about b? b equal to minus 6 minus 4. Minus 6 minus a. And in this case, we have minus 6 minus 4. So we have plus 4 equal to minus 2. So we have our last pair, minus 4 and minus 2. And let's gather all the roots together and let's write our final answer, and in the end we will check it. So our answer to this question, we have 4 pairs. Our answer, if we're talking about pair, we're interested in a and b. So first pair we have, let's start with addition. So 4, 2, then combination 4 minus 2. Okay, let's start with 4, 2. We have second one 4 minus 2. The third one minus 4 and 2, and the last one minus 4 and minus 2. And in the end, let's check real quick our pair. So we have a square minus b square equal to 12. And a lot of students, they solve this question like that. They try to solve this question by inspection, and they easily see that 16 minus 4 equal to 12. That's why they think that 4 and 2, this pair, is only one correct pair for this question. But in this case, we have squares, so that's why we're interested in combination of positive and negative, and we're interested in both positive, in both negative and negative roots. For example, let's check real quick both negative right here. So let's do it. We have minus 4 square minus 2 square. So when we raise all of these negative root to the second power, we have positive. So we have 16 minus 4 equal to 12. That's why we need to mention that we have also our negative branch, negative root, which is also really good. So right here 16 minus 4, right here 16 minus 4, 16 minus 4, and in the last case we have the same thing. So that's why we are interested in these cases. But if you need to solve this question completely, you need to like not only for integers, because right here we are talking about integers. This is our integer roots. But if you need to solve this question completely, well, it will be a little bit difficult for you, because you need to solve for all of these all of these cases. As you can see right here, we have 6 negative, 6 positive, but in this case we need to solve it for integers. That's why we reject for system of equations and we solve for a negative one. I really hope you understand my explanation. I really hope you understand my solution. Write your thoughts in the comments below, write your answer, write your respond. And thank you for watching. See you in the next videos and take care of yourself.